it is because of a lack or absence of intelligence that we require algebraic expressions. Let me explain. For example, if I tell you that you go to a shop and you buy, say, 5 sweets, and the total cost came out to be rupees 50. Okay, so basically here I'm writing the number of chocolates and here I'm writing down the total cost. If I bought 8 chocolates, it costed me rupees 80 from the same shop. Okay, so everything is happening in the same shop. And if I bought, say, 10 chocolates, it costed me rupees 100. Tell me, if I buy 7 chocolates, what will be the total cost? 70. It'll be 70, correct? Very easy to answer. But if I had asked the same thing to a computer, can it, and you have given these 3 pieces of information to the computer also. Okay, that see, when I bought 5 chocolates, it cost 50. If I bought 8, it cost 80. If I bought 10, it cost 100. If I buy 7 chocolates, how much would it cost? Do you think the computer will be able to answer? Let me tell you, it won't be able to answer. It won't be able to answer. It is because we humans have intelligence that we can correlate the linear proportion between the number of chocolates bought and the total cost. In lack of intelligence, such an argument or such a conclusion cannot be made. Right? If I buy 8 chocolates, will the computer be able to answer the total cost? Yes, this it will be able to answer because it has been fed the information of what should be the total cost when you are buying 8 chocolates. The computer already knows that if I buy 8 chocolates, the cost is 80. This piece of information the computer already had stored in its memory. So how do we teach a computer to answer questions, any question? Like, for example, if I buy 15 chocolates, how much would it cost? How am I going to teach the computer to answer this question? One solution that you might come to is that, sir, let's feed in all the values. 1 se shuru karke, we'll put in 1, 2, 3, 4, 5, 6, 7. Suppose we have a store and it can sell at max 1000 chocolates. We are going to make the computer, we are going to feed each and every cost value to the computer, right? And then if some customer comes and asks, let's see, if I'm buying 200 chocolates, what will be the total cost? Computer would know that it's going to be 2000 because we have fed in the value for all 1000 cases, correct? But there is a very big problem with this procedure. Number one, it is going to waste your time teaching the computer so much. Second of all, it is going to use up a lot of memory of the computer. Therefore, this is not such a good idea. Instead, what we should do, and what is actually done in real life, is that we introduce a variable, right? We say that, see, whatever is the user inputting, remember it in a storage value, call it X. Okay, we introduce a new symbol to the computer, say a new character called X. Say that whatever value is inputted, replace that with X, right? And then when they ask you the cost, simply give the answer for 10x. Whatever your x is, take x multiplied with 10 and give that as the output. Then the computer won't have to remember everything beforehand. It can answer to anything, right? If you ask that how many chocolates, what would be the total cost if you buy 7 chocolates, the computer will answer now 70, right? Even though it was not fed earlier what would be the total cost if the customer bought 7 chocolates, but now it can answer because we have taught the computer in terms of an algebraic expression. We have fed an algebraic expression for the total cost and an expression for the input. And that is how we have managed the problem of lack of intelligence by introducing an algebraic expression. The point is, so you might be feeling that, sir, so you're telling us that we are learning algebraic expression just so that we can teach machines that have no intelligence how to solve problems. Is that the only use of algebraic expression? Notice that when I told you what is the importance of algebraic expression, it is not only used where there is absence of intelligence, we also use it where we feel a lack of intelligence. And believe it or not, the first case of lack of intelligence starts with human beings. All of us have lack of intelligence. All of us. We could be Einstein, but still we have lack of intelligence. Of course, there is a matter of intelligence. We lack intelligence. That is why we take time to solve problem. Correct? Many a times the problems are of such difficulty that we might not even be able to figure out the answer, even if we spend say 5 minutes, 6 minutes, 7 minutes with the problem. That is again where algebraic expressions come to help us. Let me give you an example. For example, I tell you that there is a right angle triangle. Sides are A, B, and the longest side is C. The two shorter sides are A and B, and the longest side is C. And now I start giving you pieces of information. I start telling you I start telling you that, see, I'm going to tell you what is the values of A, B, and C, 3 or 4 values, and then you'll have to start telling me the next one. For let's say that I tell you that when the sides are 3 and 4, the longest side is going to be 5. Okay, and this is a right angle triangle. Uh, when the sides are say 6 and 8, the longest side is 10, right? If the sides are uh, okay, suppose I give you these two pieces of information and then I ask you that if the sides are 5 and 12, what do you think is going to be the length of the units? Is going to be C,
13.
right? I think that in this class everybody will be able to answer this question, that it is 13, right? It's 13. But do you know something? All of you have solved this question exactly like the computer. All of you, I'm sure. Even I, if I'd been given this question, I would have solved it like a computer. How many people have actually given the answer or thought of the answer of 13 like you thought the answer for this one as 70? Did anybody really analyze the correlation or felt the logic that because number of chocolates, each chocolate is having the same price, so if you buy 7 chocolates, the cost will be 7 plus 7, I mean 10 plus 10 plus 10 plus 7 times, and then the answer is 70? Like this is the thinking that goes on. It's a simple question, so that the thinking goes very quickly, and then logically you answer 70. This answer I'm sure nobody has given logically. This answer you have answered like a machine. Let me tell you how would the thought process seem like if you would have tried to do it logically, like the previous case. Okay, first of all, you'd be stuck. I would have been stuck if I tried to do it logically. I have been fed two pieces of information, but still, I don't think I'll be able to answer this very quickly. First, I'll try to find a pattern. Okay, these are consecutive numbers, and these are doubled, but still it is difficult to see the pattern here, right? So I stop thinking about the pattern now. Because I'm a human being, I start thinking about the logic, right? Okay, I start thinking about the logic about, if I know the two sides, how can I figure out the third side? Because that is the problem that I'm facing with, correct? So I start with a fresh page, and it's going to be difficult. You're not going to get an idea right out that what should be the. It's not evident, right? If I tell you this side is 5, this side is 12, 13 doesn't pop into your mind. लग रहा है कि 13 ही होगा, ऐसा तो नहीं बोल सकते, है ना? We can. It's not a very simple. If it were a square, I told you this side is 5, this side is 5. I ask you what is this side, you'll say 5. This pops directly into your head. But it's not very easy to think what should be this side. Correct? We have to think about it logically, and it's going to take some time. So let me draw a right angle triangle, and then let me start thinking. Okay, how would you solve? How would you solve the problem of the unknown length? Any idea?
Could we form a rectangle?
Okay, let's form a rectangle. This will help you people understand how difficult life would be without algebraic expression if you didn't have x or any variable in maths. Okay, now we have a rectangle. What do we do next? Tell me.
I'm thinking about that one.
And at first we are stuck. Urvi gave an idea that let's draw a rectangle and think. But how are we going to find out this length? It's still difficult. Let me save some time, and let me show you the procedure. How would you do it if you do it logically? And there are multiple ways. I'll just show you one way. Okay. What we are going to do is we are going to draw the triangle. Okay. And I am going to take a duplicate of the same triangle. Actually, not one duplicate, but 3 more duplicates. Okay. So I'm going to take 3 more duplicates, and I'm going to arrange them all in a particular way. I'll show you in a moment how. Okay. The first one, I place it here. The second one, I am going to rotate it like this. I'm going to place it like this. The next one, I am going to rotate it by 180 degrees. And I'm going to place it like
एक स्क्वायर बन जाएगा.
एकदम. बट ये बहुत ध्यान से करना होगा कि पूरा साइज सेम निकल के आए, वरना ना गड़बड़ हो जाएगा. वो ठीक है, मैं यहाँ पर ऐसे एक रफली दिखा रहा हूँ, फिर नेक्स्ट पेज में एक डायरेक्ट फेयर बना दूंगा. So I am going to create a figure like this. I am going to make 4 replicas of the same triangle, and I'm going to arrange them by giving them 90 degree, 180 degree and 270 degrees rotation each. Understood? And finally, what would the shape look like? Let me show you what the shape would look like. यहाँ तो gap है, क्योंकि मैं तो resize कर रहा हूँ तो ठीक से हो नहीं रहा duplicate. So actually the shape is going to look like this. Let me show you how. Or rather, और ज़्यादा एकदम ही परफेक्शनिस्ट बन जाते हैं, काम करते हैं। वाह, ठीक है। तो दिस सीम्स टू बी अ good representation of what we wanted to do. Okay, so 5 12 12 5 12 5, ठीक है। Now first of all, do you all agree that the big shape that we have created is a big square? क्या सब लोग ये बात मानोगे that it's a big square? How do we know it's a big
Yes, sir.
square? It's simple.
All sides are same.
All sides are of the same length plus all of the angles are 90 degrees. ये दोनों बात बोलना होगा। देखो, all sides same length होने से rhombus भी हो सकता है, इसलिए not only are all the sides of the same length, right, also all of the angles are 90 degree because ये सभी लोग right angle triangle थे, है ना। अच्छा, what is the side of the big triangle? ये बड़ा वाला triangle का sorry, बड़ा वाला square का side क्या है? What is the side length?
17.
17. बहुत अच्छा, 17, very good. अच्छा, do you people also realize that we have formed another square? एक void square बन गया बीच में। Does everybody agree with me that this is a void square? How do we know that this is a square exactly? पहला बात तो this length equals to this length equals to this length equals to this length, because ये तो रेप्लिका है ना, तो ये longest side तो हर जगह मिल जाएगा हम लोग को, same longest side. But how do we know that these are 90 degrees? Anybody would like to tell me how do we know that this angle is 90 degree? Is it 90 degree? ये square है भी या नहीं?
Sir, since all of the triangles are same, तो वो बीच वाला 90 होगा क्योंकि like the corner angles are 90 and the sum of the other two angles of each triangle have to be 90.
Very good.
So
So
on
we
either side of
leave
one
it
corner of the square they have to be 90. So this
correct.
angle of the square becomes
Correct.
90.
देखो, इस ट्रायंगल में दिस इज x दिस इज y, x प्लस y करने से तो 90 आना चाहिए, है ना। राइट एंगल ट्रायंगल है भाई, तो ये 90 है, तो ये दोनों मिला के बचा हुआ 90 होना चाहिए। अब यू सी, इसमें x इधर है, y इधर है, करेक्ट। सो यू सी इन दिस line, on this line sits x, y and this angle. We know x plus y is 90 degree, therefore what remains must also be 90, and this can be explained for all four vertices. So now we can be sure कि भाई this is indeed a square, all of these are 90 degrees, ठीक है। so much trouble to show that this is a square, but now we know that this is a square. बाहर वाला भी, बड़ा वाला भी square है, अंदर वाला भी square है, शानदार। अब मैं क्या करूंगा, see what I'm going to do is I am going to write down an expression equating areas. How? Let's give these figures a name. Let's call the bigger square ABCD. Let's call the smaller square PQRS. क्या तुम लोग मेरा ये बात मानोगे जब मैं बोलूंगा एरिया ABCD, एरिया ऑफ द बिग स्क्वायर ABCD इज द एरिया ऑफ ट्रायंगल PDS टाइम्स 4, है ना, टाइम्स 4 प्लस द एरिया ऑफ स्क्वायर PQRS। मानोगे ये बात?
Yes, sir.
This is true, right? Area of the big square ABCD will be the area of these four triangles, which is nothing but this area times 4 because it's the same triangle, plus the area of PQRS, right? So I can say area of the big square ABCD is going to be 17 square, क्योंकि स्क्वायर का एरिया कैसे निकालते हो, साइड इनटू साइड, राइट, और साइड पता है 17 है। 17 स्क्वायर इज इक्वल्स टू एरिया ऑफ PDS टाइम्स 4। PDS, इस ट्रायंगल का एरिया कैसे निकलेगा, हाफ इंटू 5 इंटू 12 करके, करेक्ट। सो हाफ इंटू 5 इंटू 12 से PDS के एरिया, उसको पूरा को 4 से मल्टीप्लाई कर देंगे और फिर बाद में उसमें एरिया ऑफ PQRS ऐड कर देंगे, करेक्ट। तो ये क्या आ जा रहा है भाई, ये आ जा रहा है 13 into 4 120, तो 289 इज इक्वल्स टू 120 प्लस एरिया PQRS। तो एक बात बताओ, इससे एरिया PQRS क्या निकल के आ रहा है, 289 माइनस 120।
Yes,
So
sir.
we get area of square PQRS, जो बीच में void square बन रहा है, it has an area of 169, करेक्ट। अब अगर मेरे को PQRS का एरिया पता रहेगा तो क्या इससे मेरा PS साइड नहीं निकल जाएगा, साइड ऑफ द स्क्वायर, एरिया ऑफ द स्क्वायर पता है तो उससे साइड ऑफ द स्क्वायर निकल जाएगा। Therefore I can say PS is nothing but the square root of 169. PS is the side of the square, so the square root of 169, which is going to be 13 centimeters. Or finally we have been able to calculate the length of the third side and it came out to be 13 centimeters. And we can now proudly, like a human being, feel that this is going to be 13 centimeter. But if you be honest, Has anybody used logic to answer 13? Did anybody really use logic? I don't think so. Neither do I. And nor do I expect that anybody will use logic, nor should you, because it's going to take a lot of time, right? It's going to take a lot of thought and time to answer a question like this one if you try to do it by logic. So what did you do? You did it like a computer, but you'll have to understand and appreciate that why you were able to do it like a computer, because the person who had figured out this strategy, probably Mr. Pythagoras, had once and for all, he knew that people are not going to spend so much thought and time to always try to find the length of the longest side. So what he did was he solved the problem once and for all case, by saying that suppose I can summon a square. Suppose we have a right angle triangle, two of its sides are known. So what he did was he tried to understand the situation in general. Like this. Let's say the two shorter sides are A and B. So A, B, A, B, A, B, A, B. Correct? Now, what is the length of the side of the bigger square? What is the length of the bigger square? Side of the bigger square? A plus B units. Think about this. Area of this big square, it's going to be A plus B because that's the side. A plus B ka whole square, side square, right, is equal to area of the small triangle times 4 plus area of the void square, है ना? So what is the area of this triangle? Half AB, half into base into height, half AB, तो half AB times 4 कर देंगे because we have 4 such triangles, plus area of the central square, area of the square inside it. तो क्या आ रहा है भाई? Either this became 2, a plus b whole square is a square plus 2ab plus b squared is equals to 2ab plus area of square, correct? So we get area of square, ये 2ab भी कट गया, we get area of square is equals to a squared plus b squared. And what is the area of this internal square? Isn't it equal to c square? Correct? Mr. Pythagoras has considered variables and then explained us the situation कि whenever you have a right angle triangle with two shorter sides as a and b, then you can always calculate the longer side by taking the sum of the squares of the two shorter side and then root it to finally find the value of c. And that is how you have found the answer 13 so quickly, like a computer. See, you might be thinking, the computer is so stupid, couldn't realize the correlation, right? And we had to feed it with variables for it to be able to answer the total cost. But see, that is how we are doing maths and solving most of the problems in our daily life on a daily basis. Correct? We answer this question using expressions in our head like a computer. Right? We say, okay, square plus b square, yeah, we are plugging in. It's so much like a computer, right? So now I hope you realize that algebraic expressions are used not only where there is absence of intelligence, but also where there is lack of intelligence. Now, don't take lack of intelligence in a derogatory way. I'm just trying to tell you that we all have lack of intelligence, and that is why at least we should be happy that we came up with algebraic expressions, right? Because we are going to save a lot of time. Even when you have intelligence, if you try to think logically, you'll waste a lot of time, right? Because if you're trying to build a bridge, at every step of building the bridge, if you're trying to say, no, I'm not going to use any algebraic expression, I'm not a computer, I'm a human. But of course, that is going to take a lot of time. You'll take ages trying to build the bridge then. So you need to make the calculations and the conclusions fast, and that is why the algebraic expressions are going to help us. Is this clear to all of you? Why we require algebraic expressions? Now
Yes.
coming to the topic of polynomials specifically. See, suddenly when you go to class 9, 10, they complicate the name of the chapter from algebraic expressions to polynomials.